Hi, this is Analog Sky Bloom, and I'm Robert, the designer of Bloom. So I'm going to take you through a quick 10-minute tour of all of Bloom's features and how they work. One thing I want to mention before we get started, we are here in studio. I wanted to do this video kind of out in the field, but it's really smoky where we're at here in Oregon right now. And so doing it here in the studio, one issue is our floor is all covered in EVA foam that's almost impossible to take up. And that foam has a carpet on top of it. So you're going to see Bloom wobbling a little bit just because the tripod down here is literally sitting on top of a carpet, sitting on top of EVA foam. But that is not something that you would experience using Bloom in a normal environment. Let's start with the powerhouse of Bloom. Two 8-inch mirrors hidden down in here. The light comes in through the top from the sky, bounces off the mirrors down there, and that light bounces back up to these secondary mirrors. The secondary mirrors move the light down to a pair of tertiary mirrors down here that get bounced up to the eyepieces where we look through. So we're looking through here, and that means that we're actually sitting toward the binoculars like this when we use them, and we are looking at what's directly behind us. So that's why we call these reverse binoculars. And we're going to talk about what special features Bloom has for the first time to make reverse binoculars a real joy to use. All of this cool stuff helps to keep these two images perfectly aligned to each other. And sometimes when you see people build these reverse binoculars, they will basically just build two telescopes right next to each other with maybe some kind of connection in the middle. Believe it or not, this doesn't work great because the picture that is formed in our binoculars is anywhere from 7 millimeters across to 1 millimeter across. So you can imagine that if there's even a 0.1 millimeter difference, that can be huge in terms of how those two sides of your binoculars are aligned. Bloom is different. It's not just two telescopes stuck together, it's actually designed as binoculars. So this top deck is one piece of aluminum that's been laser cut, and all the holes have been drilled and tapped so that all of these components stay perfectly aligned to each other. This truss system of aluminum tubes is also very rigid. It uses triangles to maintain its shape so that when we move Bloom around, it stays all aligned. Everything is still exactly where we left it. So as you move all the way from zenith all the way down to the horizon, it doesn't lose the merging between the two images. Let's talk about where the eyepieces go. So these are the focusers of Bloom, and they squish all the way down to 56 millimeters apart. That means over 95% of people can use Bloom. It's the same basically as handheld binoculars. So we put these eyepieces in, and then we're able to change how far apart they are by twisting these knobs, moving in and out. You'll notice up here that our secondary mirrors are rotating as we change that interpupillary distance, and there are gears up here so that this side and this side are perfectly in sync with each other. And that means that these two eyepieces are always kept on the same level. There isn't one that's rotating a little bit more than the other. So these gears allow perfect alignment of these two eyepieces no matter which interpupillary distance we use. This IPD goes all the way, like I say, for our 2-inch eyepieces, IPD can go all the way from 56 millimeters apart all the way out to 85 millimeters apart. And for those of you who are 56 or below, we are going to be able to pull these focusers off and use 1¼ focusers. So you won't be able to use the 2-inch eyepieces, but what you will be able to do is get these two sides all the way down to 49 millimeters apart, which will be a world record for binocular telescopes anywhere in the world, and it will allow absolutely anyone to use these. That will be well over 99% of the human population will be able to use Bloom with those 1¼ focusers. But these 2-inchers, like I say, same as any handheld 50 millimeter binocular, and it covers just about anybody. So the reason that we change these eyepieces in and out is to select our zoom level. So these are 36 millimeter eyepieces, and these give us a super wide view, 2.5 degrees across. That's a huge chunk of the sky. So you're seeing some of the biggest objects in their entirety. You're seeing objects with a ton of beautiful star fields all around them. Now, if we want to zoom in more, we just remove these eyepieces And then we can choose a more zoomed in eyepiece, like these 26mm eyepieces. These just slot in like so. And now we're able to view with those. When we put in new eyepieces, we have to adjust the focus because every eyepiece has a little bit different focal point. And so to change focus in Bloom, all we have to do is rotate each eyepiece. So you have individual focus control of each eyepiece. You can move in and out, and that allows us to change the focus for different eyepieces or for different people. In an outreach event where you have 100 people lined up to take a look through this, it's really quick and easy if people have different vision to adjust the focus for them. So we can focus for our eyepieces by rotating these helical focusers. These give you very fine focus all the way up to viewing at 250x, 300x. You're able to focus even at those really high magnifications with these helical focusers. Now, as you can imagine, Bloom is a real nebula beast. So being able to see nebulas at their best usually means using filters. So we have magnetic filter cartridges to make this really quick and easy. We have these little docking bays out here, and that allows us to store 4 different filters just within arm's reach. So we're sitting here and we want to add our filters. I grab this filter, I pop it in here, I grab this filter, I pop it in here, and I didn't have to go back to my car to grab the filters. I didn't have to go back to a box, open up the box, open up the little filter box, carefully take out the filter, remove the eyepiece, screw in the filter, and then put the eyepiece back in and refocus the eyepiece, and then pull out this eyepiece and screw in that filter, and then put that back in. We skipped all of that by having these magnetic filter cartridges, which no other binocular telescope in the world has, unless you get one custom made that does that. So that's amazing for being able to quickly check out, okay, what kind of nebula is this? What's going to look best? This is my O3 filter. Maybe I want to try my UHC type filter. Well, I just pop that in and it's ready to go. If I have my filters in and I decide I want to change the eyepieces, again, usually what you have to do is you have to remove your eyepiece, unscrew the filter from your eyepiece. Let's say we wanted to move to an 1¼ inch eyepiece. Now I have to take my 2-inch filter, put it back in its case, open up my 1¼ inch filter that I had to buy extra, take that out of its case, grab my 1¼ inch eyepiece and put that 1¼ inch filter onto the end of this eyepiece, and then finally stuff this eyepiece into the focuser, and then I have to do that again. I would have to do that all over again. Unscrew the 2-inch filter, put it back in the box, put down my 2-inch eyepiece, grab my 1¼ inch eyepiece, open up the box for the 1¼ inch filter at night in the dark, thread it carefully onto the end of the eyepiece, and then put the eyepiece into here. As you can see, I just skipped that entire process because the filters are totally independent of the eyepieces. Also, Analog Sky has 80mm binocular telescope and 50mm binocular telescope that also use the same filter cartridge system. So you can buy one set of filters that you can swap in real time between any of your Analog Sky binoculars. Alright, so we've changed out our eyepieces, we've played with filters, and let's say these eyepieces weren't manufactured exactly perfectly the same. Maybe this eyepiece moves the image a little bit down, and this eyepiece moves the image a little bit to the right, just because the lenses aren't perfectly centered. Well, guess what? In another binocular telescope, you're just out of luck. And you'll notice that that's why when a lot of people talk about their binocular telescopes, they're like, well, I don't really use any eyepieces that are lower than, I don't know, a 10 or a 12 millimeter, because, you know, the alignment, you can't do anything about it. Well, we have 2 knobs. We just have a knob here that moves this mirror vertically, and this mirror over here gets moved horizontally. And so you just turn this knob a little bit, and that moves the image up and down, and you turn this knob a little bit, and that moves the image left and right. And so you can merge any pair of eyepieces with Bloom. just by using these two knobs. And in the final version, those knobs are going to be big. These are little small ones that are prototype version, but the big ones are going to be really nice and easy to use in the dark. And so, you know, that's a completely different new thing, to be able to perfectly merge this binocular telescope all the way up to 300x with a 3mm eyepiece, no sweat whatsoever, and then to move it all over the sky. It maintains perfect alignment no matter where you move it, and you know, that's that's the way it's supposed to work. So we have this system for being able to change out any eyepieces you want, being able to change out any filters you want, and as you can see, you can keep 3 pairs of eyepieces down here and have 1 up here in the machine, and so you are totally ready to explore the sky. Movement is really smooth. We have full control in the azimuth and the altitude, and that is thanks to these huge Dobsonian altitude trunnions, and that helps us balance our big eyepieces with the mirrors in the back. There's also an offset this direction so that the mirrors keep these eyepieces perfectly balanced. So a lot of times people will just build their binocular telescope where the balance is just split down the middle, or the center of gravity is aligned to those mirrors in the back, and then your heavy eyepieces that are hanging off the bottom will pull this machine all the way down to the ground just because they're hanging down lower. And then you'll see some kind of ugly stack of very heavy weights in the back of the mirror box to help balance that out. Bloom is designed so that the center of gravity is between the eyepieces and the mirrors, so that that vertical balance is maintained. So these altitude bearings do a great job of allowing us to move up and down in the sky, and we are experimenting also with adding motion control devices, which are the same little geared system that allows like a glove box in a fancy car to open smoothly, or cabinet doors to open and close smoothly. Same kind of thing. That's what these little brackets here are for, and we will probably release with the ability to use those. So like I said, this is a reverse binocular. You are looking through these eyepieces, and your back is to what you're looking at. So usually when you are navigating the sky and enjoying the sky, you're looking at the constellations and saying, I want to go there, and so you point your telescope there. Well, it's very hard to do when that's behind you. So typically with a reverse binocular, what you have to do is you have to get up out of your seat, you have to stand up back here, and then you have to look through a red dot sight that's mounted up here, or maybe use the green laser. We have a green laser that's built in up here that hides behind this little safety window. So you can push the green laser button and you can sit here and kind of move around in the sky with the green laser. That's one option, and that's really handy. But another is this amazing PiFinder. So the PiFinder has a camera right here, and we have a little cover for that camera lens to keep it safe. We open that up, and then the PiFinder itself is this cool Raspberry Pi based computer, and it uses the camera to figure out where it's pointed. It has a really great chart up here in this screen. The final version, this is an 1.5 inch screen, but the final version will have a big 2-inch screen that's the full width of this whole cavity here. So it'll be a nice big bright screen for you to look at that'll be really easy to see in the dark. Or you can adjust the brightness however you want with these buttons here. You can adjust the brightness at a dark site so that I think you can see the brightness of those little LEDs going down, down, down. So you can adjust it really nicely. But anyhow, this has a chart in it. So you can be sitting here and you can be watching the chart move, and you can zoom in on the chart, you can zoom out on the chart, and you can move around within the constellation you're in if you know what you're looking for, or you can move to a totally different constellation. You never have to get up and go around behind this thing to do that because you have that chart right there. Now you can also plug in the number and name of an object that you actually want to see, and then PiFinder will also tell you how to get to that, and it will give you directions for how far to go. Now in an outreach situation, that's really cool because you can plug an object into that PiFinder and then that's kind of home base, right? So you find that, and then that's at 0, 0, 0, and then people can move around the sky, but then when it's time to move it back for the next person to take a look, all you have to do, you can stand right here on the side and you just zero out those numbers, and it's ready to go. You don't have to sit in front of it and find that object again for the next person. So this PiFinder really revolutionizes using a reverse binocular, because you are sitting here at this workstation where you're changing out eyepieces, you're changing out filters, and you have a map of the entire sky sitting right here. And so you're not constantly having to get up back here and figure out where in the sky you're going to point next. One great feature is this hand controller. So this hand controller has a 4-way button that goes up, down, left, right. You click it in the middle, and that is your square button for your PiFinder, for you PiFinder fans, but that's kind of one of your main buttons. And then you have the plus and minus buttons are right here. So zooming in and out of your chart, you don't have to kind of, if you're moving around the sky and you're holding here to do that, we're moving around the sky like this, and then you don't want to have to go up here and hit the plus and minus button to zoom in and out of your chart. Well, if you have this hand controller right here, look at this. I can just plus and minus on my chart. I'm looking at my chart, zooming in, making fine adjustments to where I want to be, and I never have to take my hands off of the unit. We can talk materials real quick. You have some stainless hardware here, like our spider vanes. These are very stiff, thin, stainless. These brackets are stainless just to maintain really rigid alignment. Most of the rest of the frame is powder-coated aluminum. It's a beautiful powder coat that's done by Send Cut Send down in Reno, Nevada. We have all stainless fasteners. You see a lot of little screw heads here. Those are mostly M4 bolts, and so we just use a little hex wrench to put all of those together. It's a nice size because it's strong and easy to work with. It's not so small that you're constantly dropping them. So these M4 bolts are all stainless. Some of them will be black as well, just to make sure that they're not interfering with the light path. We have a lot of PETG. So anywhere you see 3D printed parts, those are PETG parts. It's a really strong plastic. So these draw tubes here have what we call grip fins, and they're little fins that grab onto the walls of this eyepiece to perfectly center that eyepiece. And that is a feature exclusive to our focusers. Everyone else wants to make things out of metal because, as everyone knows, good telescopes are made 100% out of metal, right? Well, that's not really true anymore. There are a lot of good uses for plastic, and you can 3D print your own parts. If you have a 3D printer, the great part of that is we come up with a new version of a file. You just download it, print it, add it to your machine, and now you have the most recent Bloom. Or if you don't have a printer, we're happy to print all those parts for you, and then we always allow people to purchase those major upgrade parts directly from us as well. Now, these truss clamps over here that connect our aluminum tubes to the frame, this is also PETG. These clamps work really well. We have stainless bolts that clamp them down. Like I say, that plastic, once it kind of breaks in, doesn't creep anymore, holds really strong, whether it's cold, whether it's hot. And this particular prototype has been all clamped up, clamped down to its maximum strength for 3 months now, which represents hundreds of observing sessions. Now, usually if you left the whole thing together, in between your observing, you would probably just back off of these screws to kind of let loose on those clamps so that they're not just constantly clamped all the time. So anyhow, these clamps are being tested by just being held together 24 hours a day, 7 days a week, and they are holding up great, perfect, working awesome, and stay perfectly aligned every single time. One thing that 3D printing allows us to do as well is to add baffling, micro baffling to every surface that's anywhere near the light path. So these shroud pieces here are not just a flat, smooth surface. This is a zigzag pattern of micro baffling. And so that helps to cut down on stray light coming in and bouncing off of the surface and going down into the light path and becoming scatter and reducing the contrast of your scene. So these baffles up here have that micro baffling, but also everything in the light path in here, inside of these tertiary holders, inside of our draw tubes for our focusers, everywhere along the light path where we have 3D printed parts, we add that micro baffling surface to make it the absolute blackest, highest contrast surface possible. So what you're seeing here, like I say, is a prototype. You can probably see a seam here in the shroud. That's this big black cover that keeps all of the light from coming into here. This one is currently made out of cardboard because it's the first attempt, but the shroud that comes with Bloom will be a thin plastic sheet, which will be very durable and lightweight and will travel really well, but offer light protection, and it will hold up really well in the dew. I know a lot of people are observing in dewy environments, and a lot of times those fabric dew shields get saturated with water and they start sagging down into the light path. Well, making this out of a thin sheet of plastic means that dew will just roll off of the back and you won't have that problem. So that will be fun to see that come together. And you're seeing some bright aluminum parts down in here, like the mirror box and the rocker box down here. All of those aluminum parts will be powder coated in the final version. And we're going to have a separate video that talks about where we're at with this prototype and kind of what's going to get finished up by production time, and also where we're going with fun new upgrades in the future. So that will be covered in a separate video, but for now it's good to know all of those aluminum parts will be black powder coated so that we don't have a bunch of stray light bouncing around near the light path. All right. All right, so as you can see, this is a real thing that really works. It's not just a prototype for show. All the features here are almost ready to go. We do have a full spreadsheet of prototyping items that we are wrapping up. We make that public to our early access customers, so everyone has access to where all of those features are at on the timeline and what the latest developments are for moving from this prototype version to the finished production model. And of course, at Analog Sky, it's never really the finished production model because we're always updating parts based on customer feedback. Of course, the printed parts, we're able to just reprint those and ship them out, or people can print them themselves. If they are metal parts that need adjustment, then we get new metal parts made, and then depending on the nature of the issue, if it's kind of a critical issue, we just ship those out to customers. And if it's more of an upgrade, like, hey, we figured out a way to make this better, then we just make those available at a really attractive price so that people can be running the latest version. So hopefully this tour shows you a little bit more about why Bloom is such an awesome workstation for exploring the sky. Really, you're sitting right here, you have all of your eyepieces, you have all of your filters, you have an electronic chart, you have a camera that helps you find where you want to go or tells you what you just found. So you can sit here for an hour straight and enjoy an entire constellation's worth of deep space objects, and it's just such a treat. And so, of course, having both of your eyes open, you're not getting fatigued. You're actually looking through the instrument that whole hour and just enjoying panorama after panorama of beautiful objects, zooming in, checking out what it looks like with a filter, popping the filters back out, putting them back here. is just an extraordinary experience. And so I'm really excited to be able to share Bloom with all of you. We have more videos coming up soon, and they're going to talk about other topics, like I say, where we're going to go with future updates, what's left to do on our prototype, and we're going to be comparing Bloom to other options you might be thinking about in terms of binoculars. So we're still trying to find those 60 people for early access. If you have any questions that you have not had answered yet, why not drop them down in the comments, and I'm happy to answer those for you. And if it's something that needs a video, I'll make a quick video about it and we can talk. All right, thanks a lot. Till next time, clear skies.